All right, and I am recording this just so you know. Phone should be away. Let's go. All right, so a zero exponent. We're going to talk about that first. Come on. Well, you had all lunch to do that. A zero exponent. All right, this can come in very, very handy. It says under the words part, any non-zero number raised to the zero power is equal to 1. So you really need to box that in. And more importantly than that, you need to remember that it's equal to 1. It's not equal to 0. Okay? There is a great proof somewhere that explains and demonstrates all of it, but it's above my pay grade. So I'm not going to show you the proof. You're just going to have to trust me. Anything to the 0 power is 1. And they give you lots of examples. 30 to the 0 power is 1. X divided by y, all in parentheses, to the 0 power is 1. 8/3 to the 0 power is 1. So let's take a look at our two examples. And you might be saying, Miss Thede, yeah, but we did what was in parentheses first. You're right. And whatever this is in parentheses, ooh, that's really wide. Whatever this is in parentheses, okay, it doesn't really matter. Because once you take it to the 0 power, it's all just going to be 1. Okay? So that whole mess of one monomial divided by another is just 1. Okay? Let's take a look at letter B. B says a to the 4th times b to the 0, all divided by a to the 2nd, or a squared, and we need to simplify that. Okay, first of all, let's go with what we know. B to the 0, anything to the 0 power, that's going to be a 1 times 1. So now we have a to the 4th times 1 divided by a to the 2nd. So we are dividing two powers that have the same base. You keep the base. And what do we do with our exponents when they're vertical? You're going to subtract. So that's a to the 4 minus 2. So the final answer times 1 is a to the 2nd power times 1 is just a squared. Any questions on that? All right. That is at the bottom of my page 9. You guys have a check at the bottom. All right, so take a look at the check. See if you can do that and decide whether the correct answer is A, B, C, or D. Yeah, I got it. Come on. It's not always like that. It's your first day. Here. She asked me. She talked to me before. It's fine. Huh? What? I don't know about that. I've let you off the hook a couple times. All right, so let's take a look at this. What do you notice? What do you do in this kind of problem? Let's make it easy. You've got g to the 0. What's that going to be? Come on, you can say it. 1 times you have an h to the 0. That's a 1. Times j to the 0 is 1. So everything on the bottom is 1. And what about 56 divided by 8? What is that? 7. So you have a 7, huh? 7. 56 divided by 8 is 7. So we have 7g squared h times j to the 11th power all over 1 would just be that top numerator part. So that is letter A. Did anybody have letter A? Really? 3 people? 3 people. Did you try it? Did I go too quick? Guys, I need to hear from you. Is there something you didn't understand, or I just went a little quick? Okay, thank you. Anybody else? All right, so now let's talk about negative exponents. We did talk about this yesterday a little bit, didn't we? Yes? Negative exponents. They don't like to be in the fractional part that they are. Did I talk about bunk beds at all? Okay. So, oftentimes if you are assigned the top bunk bed, maybe you're too scared to be up there, so you want to be down in the bottom bunk bed. If you're in the bottom bunk bed, you want to be all cool and you want to say, I want the top bunk bed. That's how I think of negative exponents. They don't like being where they are. They need to move. And after they have moved, you remove that negative exponent. Okay? So, I don't like the words they have here, but let's take a look at the symbols. For any non-zero number a and any integer n, a to the negative n, you might want to box this, is equal to 1 over a to the n. So this was in the numerator, and then it moves to the denominator, and the negative exponent is removed. The negative. You just remove it. And vice versa. If you have 1 over m to the negative 3, it doesn't like being on the bottom part of the denominator. So you would rewrite it and move it so it goes to the top, is m to the positive 3. You lose that negative on the exponent and put it over 1. Okay? So 3 to the negative 5th becomes 1 over 3 to the positive 5th. And then, yes, you do need to simplify it because we can take 3 to the 5th power. 1 over m to the negative 2nd, doesn't like being on the bottom, move it to the top. Becomes m to the positive 2nd over 1. Any questions on how to read those? All right, so all of these problems, we want to simplify them. We want them in simplest form. So these 4 statements are very, very important, okay? So an expression is considered to be in simplest form when it only has positive exponents. You cannot leave an expression with negative exponents. So no negative exponents. Okay? If it says simplify, don't leave a negative exponent. Number 2, each base appears exactly once. Okay? So you can't have e to the 2nd, f, e to the 1st. You would be able to simplify that, right? Because they're being multiplied, it would be e to the 3rd, f. So you only can have one variable written once. Number 3, there are no powers of powers. So you can't say m to the 3rd and raise that to the 5th and leave it like that. You would have to multiply, and that should be m to the 15th. And finally, this is the most difficult one because sometimes we don't know what numbers divide into the other numbers. All fractions have to be in simplest form. Put it away. Okay. All right, so let's take a look at example 2. We have a to the third, b to the negative fourth, divided by c to the negative second. First of all, do you see any repeats of your bases or your variables? No. Okay. But I do see that we have some negative exponents. So first up, and you just take it step by step, a to the third. There is no other a. There's nothing wrong with that. So I'm just going to leave that as a to the third power. Aiden, you with me? Where's your packet? Okay. I appreciate that you're taking notes. That's good. Next up, we have b to the negative fourth. That negative 4 says I am not going to stay in the numerator. So we are going to move it down, and that is going to be b to the fourth in the denominator. And you remove the negative sign. Finally, we have c to the negative 2. It doesn't like being in the denominator, so you are going to move it up into the top numerator, and when you do, you remove the negative sign. I don't have any other repeats of my variables or bases, so this is your final answer. A to the third, c squared, all divided by b to the fourth. Questions on that? Okay. Let's go to the next one. The check. Let's see. Simplify. I'm just looking to see how much. Okay. So we got 1, 2, 3, 4. Let's start with A. Okay. So as I look at this, I see this is mostly a division problem because I see that I have the same base in the top and the bottom. All right. So I am going to look at each of these individually. First up, 18 divided by 6. What is 18 divided by 6? 3. 18 divided by 6 is 3. And I know I'm going to have some kind of line here, so 3 is going to go on top. If I wanted, I could put the 1 on the bottom. I'm not going to do that right now, though. All right? Then I have a to the negative third and divided by a to the negative fifth. All right. So a to the negative third doesn't like to be on the top part. So I'm going to move that down and make that a to the positive third. And then I see that a to the negative 5 doesn't like to be in the bottom part of that fraction. So that's going to get moved to the top. And I'm going to remove that negative sign on the exponent. Then I look at my b's. I have b to the 7th. Whoops. Just erased it all. B to the 7th divided by b. There's no exponent on it. What should I do? Put a 1 on it. Okay? Now, we are dividing. When you divide and you have bases that are the same, you keep the base. And what do I do with the exponents? Subtract. Yes, if they are vertical, you are going to subtract. So this is b to the 7 minus 1. And lastly, I have c to the negative 4 divided by c squared. C to the negative 4, let's deal with that first. It does not like being in the top. So it's going to go to the bottom, and that becomes c to the positive 4, where I remove the negative sign. What about that c squared? Do I need to move that one? No, it's not got a negative exponent. So I just put times c squared and keep it there. Okay? And again, some of you are going to want to do several steps at the same time, but just work it out step by step. All right, so I need to simplify this. 3 is still the only number I have up there, so that's going to stay. I have a to the 5th divided by a to the 3rd. I'm going to keep that base of a, and I'm going to subtract my exponents. So that becomes a to the 5 minus 3. B, there's only one b there. It says b to the 7 minus 1, so that is b to the 6th power. So I've taken care of that. And finally, I have in the denominator c to the 4th times c squared. So I have two c's, two powers that I'm multiplying. I am going to keep that base. And what do we do with the exponents when the bases are the same? We add them. So 4 plus 2 is c to the 6th. All right, we're almost done. So just clean it up. That's going to be 3, a to the 2nd, b to the 6th, all divided by c to the 6th power. I don't have any negative exponents. I don't have any fractions that I need to put in simplest form. I don't have any repeats of my bases or my variables. So this is my final answer. Questions on that? What do you guys think of this? You like it? Not too bad? Yes. Why? Say it one more time. Why did I move what? Why didn't I move it next to the C? Well, I had a to the 5 minus 3, which is a to the 2nd. You're fine. I make mistakes all the time, don't I, class? Yes. No? Yes? Sometimes. I do. Yeah, so it's just a to the 2nd. It's not a negative 2, so it doesn't need to be moved down. It's just going to stay where it's at. Okay? All right. I'm just checking here. Let's try letter B. We'll do this one together. So, step by step, look at each one individually. Okay? So, first up, I see 21 divided by 7. 21, that's a number, divided by 7. What is 21 divided by 7? 3. And I know I'm going to have probably some in the bottom, so I'm going to put my division bar there. Then I have r to the negative 2 divided by r squared. First of all, I'm going to deal with that negative exponent. R to the negative 2, I'm going to move that down, and it's going to become r to the positive 2. Okay? Now, this second r squared is just going to stay down there for now too. Okay? So this one is the first one, which moved to the other part of the fraction, and the 1 in the denominator is just going to stay there. All right, then I have t to the negative 6. That's the only t base I have, and it's a negative power, so I'm going to move that to the bottom denominator, and it becomes t to the positive 6. You take away the negative exponent. Finally, I have u to the 3rd divided by u to the negative 3. I'm just going to keep that u to the third up here for right now, because I know I need to move that u to the negative 3. I need to move that to the top. So that becomes times u to the positive 3. Is everybody with me? Okay. All right. So to simplify, I have 3. And now I have in the numerator u to the third times u to the third. When you multiply powers that have the same base, you keep the base and you add the exponents. Okay? So that becomes u to the 6th power. Over here, underneath, I've got r squared times r squared. So you keep the r and you add the exponents. So that is r to the 4th power. And finally, I have t. It's the only t there. It's not a negative exponent, so I just keep it down in the denominator. So the final answer, 3 times u to the 6th divided by r to the 4th, t to the 6th. Does anybody think these are like little puzzles, kind of? No? What? I love this stuff. Of course, I'm a math teacher, right? Okay. One more, guys. One more. Don't pack it up yet. Simplify an expression with negative exponents. I think we've been doing that, but let's check it out. So, negative exponents. Here we go. So, look at the coefficients. Yes, that is the number out in front. I have 3 divided by negative 3. What is 3 divided by negative 3? Negative 1. Oh, yeah. Sorry. Thank you. Jeez, I didn't see that at all. I don't know what I wasn't even looking at that. Yes, it is. Thank you. Very nice. See, there's my mistake. First one the whole year. No. 3 divided by negative 36. All right. So this is where you have to say if the top number is smaller in value than the bottom number, and I'm not talking about because it's negative on the bottom, but 36 is a bigger number than 3, you have to ask yourself what number is the largest number that divides into both of them, 3 and 36. Always check with the smallest number first. Does 3 go into 36? Yes. So divide by 3, and you are going to get 1 over 12. Because 36 divided by 3 is 12, and I'm going to put the negative, I always like to put the negative with the numerator. All right, so then I have g to the negative third and g to the third. G to the negative third is going to move down and be g to the third. And you have a second g to the third. So I'm going to keep that there. Next up, I have h's. That is h to the second divided by h. Oh, there's no exponent on it. What should I do? Put a 1 on it. Okay. And then I am going to subtract. So this is going to be, put my line over here, h to the second minus 1. Okay? Because you are subtracting when they are vertical, one on top of the other. And the last one, I have j to the negative 4. Doesn't like being on the bottom, so that goes to be j to the positive 4 up in the numerator. All right. I know the bell rang. We'll stop as soon as I get done with this. And so we have negative. I have h, and that is to the first power, j to the fourth power, all divided by, I have a 12, and I have g to the third times g to the third. There is no operator there, but I know I'm multiplying. What do I do with those exponents? Add them. Keep the base, and that's going to be g to the sixth. So a clean cut answer would be negative h j to the fourth divided by 12 g to the sixth. You can leave the negative 1 in front, or you can just say negative, because negative 1 times anything is just going to leave it as negative. Good question. Negative 1 times h would be negative h. It would be the same. So, homework number 2. We have now gotten through most of 10.3, which is the notes on these negative exponents. Homework number 2, front and back, is going to be due on Wednesday. Due on Wednesday. Remember, you have the information on the inside cover of your notes. Okay? Are you comparing? Well, you guys can sit together during this time. I don't mind that. Bro. All right.